Good evening, everyone. Today we will be studying sign convention, which is a very important yet confusing topic for most of the students in chapter Light of Physics. Sign convention is very simple if we understand the basic rule. Now see, in Cartesian coordinate we have already studied about the system where we had one origin and all the measurements towards the right of the origin is taken as positive and the measurements towards the left of the origin is taken as negative. Similarly, there is a pole from where we measure all the distance. It is very much similar like the origin of the Cartesian system. But it doesn't mean that the right side of the pole will be always positive and the left side of the pole will be always negative. Here, the basic rule to decide the sign convention as stated by NCERT is the direction of the incident ray. Like here, we have taken two cases of concave mirror. In one, the object is placed on the left side, that is, the alignment is made towards the left side. Now here, if you can see, the incident ray is traveling towards right. So hence all the distances measured on the right side of the pole will be taken as positive. And all the distances which are measured from the left side of the pole will be taken as negative because the incident ray is progressing towards the right direction. In this case, the object is placed yet in front of the mirror, but here if you see the direction of propagation of incident ray, it is towards the left side, in the left direction. So all the distances measured on the left side of the pole will be considered positive and the distances measured towards the right side of the pole will be taken as negative. So in these two cases, if you see properly, the right side of the pole is not always positive and the left side of the pole is not always negative. So the basic rule is the direction of incident ray. In whichever direction the incident ray is progressing, that direction towards that side of pole will be positive and the opposite will be negative. But suppose if we get confused in understanding this rule, so there is one basic simple formula. All the distances which are taken in front of the mirror is negative. Like if an object or image is in front of the mirror, then their sign, the object distance and the image distance sign will be negative. Also, negative means real. If any object is in front of the mirror, it is a real object. Same goes for image. If an image is formed in front of the mirror, it is real and image distance will be negative. If something, whether the object or image is behind the mirror, those distances will be positive. Means if an object is behind the mirror, object distance will be positive, and if the object is in front of the mirror, its object distance will be negative. Same goes for image. Now here let us see two cases of convex mirror. Here we will try to get the sign convention with respect to the criteria whether the object or image is in front of the mirror or behind the mirror. As you can see here, as the rays are propagating towards right and also in one case means behind the mirror. So you see the behind the mirror in both the cases is positive and in front of the mirror in both the cases is negative. Similarly, as the focus of a concave mirror lies in front of the mirror, so the focal length will be always positive, and the focus of a convex mirror lies behind the mirror, hence its focal length will be always positive. Now, if an object is in front of the mirror, the object is real and the object distance is going to be negative because signs of any distance which is measured in front of the mirror is negative. Similarly, if an object is behind the mirror, the object is virtual and the object distance is positive. If an image is in front of the mirror, it is a real image and image distance will be negative. If an image is behind the mirror, it is a virtual image and it will be positive. I hope so this video helped you to clear the confusion regarding the sign convention, and now you must be finding it easy to apply in both the cases of mirror formula and lens formula. Thank you.